Hello everyone. Today's topic is number system. In this video, I am going to explain all basic concepts of number in very quick and easy way with very simple examples. So let's start. Types of numbers. There are natural numbers, whole numbers, integers, rational numbers, irrational numbers and real numbers. So I am going to tell you one by one all kind of numbers. Natural numbers. When we talk about numbers, what comes naturally in our mind? 1, 2, 3, 4, 5 and so on. So, we can relate natural numbers with naturally comes in our mind and it is noted by capital N. Now come to the whole numbers. Whole means complete. Means what is completing the number? Without 0, numbers cannot be complete. So numbers starting from 0, 1, 2, 3, 4, 5, 6 and so on are called whole numbers and it is noted by capital W. So we have infinitely many natural numbers and infinitely many whole numbers. Next, integers. A whole number which is not fraction means it's like 0, 1, 2, 3, 4 and so on. So on. What is fraction? Fraction means when we write something like 1 by 2, 3 by 4 and so on. I will discuss this fraction later on. So now in integer we are talking about integers. So 0, 1, 2, 3 and so on are integers. It is noted by capital Z. Why it is noted by capital Z? Now you can think like this, no? So Z comes from German word Zählen. It is Zählen, which means to count. Now we know all the numbers we can represent on number line like this. So 0, 1, 2, 3 and so on till infinity. We'll get from 1 to infinity we get positive integers and when we go back to the 0, minus 1, minus 2, minus 3, minus infinity we'll get negative integers. So there are positive integers, negative integers and 0 is also an integer. Moving to the next, here is prime number. A number which is divisible by itself and 1 means only it has two factors. It's called prime number. Let's take example means 2. 2 has two factors 1 and 2 itself. So 2 is a prime number and here we can note that 2 is the smallest prime number. Now take example of 3. It has 1 and 3, two factors 1 and number itself. So 3 is a prime number. Let's take another example like 13. If we write factors of 13, that would be 1 and 13. So 1 and number itself. So 13 is a prime number. Moving to the next, co-prime numbers. Co-prime, any two numbers having only one common factor which is 1. Okay, means only 1 is a common factor are called prime numbers. Let's take example 7 and 9. We have two numbers. So we will write factors of 7 that is 1 and 7 and factors of 9 that is 1, 3 and 9. So we have only 1 as a common factor in these two numbers. So 7 and 9 are prime numbers, co-prime numbers. Let's take another example like 15 and 8. 15. If we write 15, 1, 3, 5 and 15 are the factors of 15. And when we write factors of 8, that would be 1, 2, 4 and 8. So here 1 is only the common factor between 8 and 15. So 15 and 8 are co-prime numbers. Moving to the next, composite numbers. A composite number is a positive number which is not prime. Means it has factors other than 1 and number itself. Let's take an example like 4. If we write factors of 4, 1, 2 and 4. So it has more than two factors. This is composite number. Next, take another example, 6. If we write 6, 1, 2, 3 and 6, it has 4 factors. So it is also a composite number. Moving to the next, rational numbers. So a number which can be written in the form of p by q, where p and q are integers, okay, and q is not equal to 0. So now if we take 1 and 2, both are integers, and we will write it in a form of p by q, means 1 by 2, then 1 by 2 is a rational number. But as we all know, 0 is also an integer, but we cannot write 1 upon 0 because 0 cannot be in the denominator, it is undefined. So this means q is not equal to 0, and it is noted by capital Q, which is means quotient. Next, here are some examples of rational numbers: 1 by 2, 3 by 4 and 3.35, and so many, infinitely many rational numbers are here. Okay, so here rational numbers we have two cases, like terminating and non-terminating, and recurring and repeating. Okay. So let's take example 7 by 8. If we will divide 7 by 8, here would be the answer 8.875, and means remainder is 0. Means after decimal, all these this term is terminating. These kind of rational numbers are called terminating, and other than non-terminating and recurring. This, let's take another example. Means if we divide 10 by 3, we will get 3.3333. It's not ending. Means this term is not ending, non-terminating, and 3 is repeating continuously. That is called recurring or repeating. So we have decimal expansion, which is terminating or non-terminating recurring, is a rational number. I hope this is clear. Moving to the next, irrational numbers. Irrational number denoted by I, a number which cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. Now you can think, is there any number you cannot write in the form of p by q? Yes. As we all heard about root 2, root 3, root 5, root 7. These all are numbers we cannot write in the form of p by q. And the best example of irrational number is pi, because it has a value 3.1428 and so on. It never ends. Means this term is not terminating, and these digits are not repeating in any form. Okay, in any pattern, these are not repeating. So non-terminating and non-recurring are irrational numbers. Any number whose decimal expression is non-terminating and non-recurring is irrational number. Here one other example we can see 0.01011011101. Here is also, this term is non-terminating and non-recurring. Understood? Let's moving to the next, real numbers. Collection of all rational numbers and irrational numbers are called collection of real numbers, and it is denoted by capital R. Here I have, you can see this image. These are rational numbers and these are irrational numbers. Now you can see rational numbers also contains integers, whole numbers, natural numbers. How it is possible? It is possible. Like if we take example 2. So we can write 2 upon 1 also, na? And its value is 2. Means I can write this in the form of p by q. So all the integers, whole numbers and natural numbers can be written in the form of rational number. So all are rational numbers, but its opposite is not true. So all these rational numbers and irrational numbers can be represented on a number line. Every real number is represented by unique point on number line. I hope now you all understood the basic concept of number very well. Thanks for watching. See you in the next video with some new concepts of number. Bye bye.